ExxonMobil has not been in the world of structural materials before. 3 years ago, we acquired a company called Menteria, and since then we're scaling it. We see the use of hydrocarbons into sustainable structural materials as being the future. We think composites can and should replace a lot more steel and aluminium than we're seeing. And we think that the Proxxima product is going to do that. It's going to take composites to the next level, and ExxonMobil is backing it hard. We came to JEC for the first time last year. We're back this year. The stand is twice the size, and we're debating how big to be next year, but it will be onwards and upwards, I can assure you from that side. It's a good show. If you look at what Proxxima is, it's a liquid thermoset. So it's a two-part system of two liquids, right? Both liquids have the viscosity of water, so 20 centipoise. And what we do is we mix those two liquids, and then the catalyst sets off and cures and makes a solid. I like this example because literally what we've done is we put the two things together in a beaker, gone 1, 2, 3, 4, 5, and it's a snap cure. So literally we are freezing the water, curing the water in this way. There's no trick to this. That is the way it was made. So we have the ability to have this snap cure. Now, for some people, it's obviously too fast. You need to fill a mold and do things. So we also have catalysts that are latent. They will do nothing for an hour or two at room temperature, and then they're activated by temperature. So the magic of this technology is a catalyst system that can be adapted to your mold. If you have a small mold, you probably want less work time and a fast catalyst. If you have a great big mold, like the big wind blades that we're making, you need several hours before you want to cure it. You need to make sure you filled the mold first. So that's the trick, is a very tunable catalyst system and a very, very low viscosity. You know, Exxon's always looking at sustainable hydrocarbon solutions for society, all right? And we do believe that in Proxxima, we found one of those. So it's very much part of the corporate mission of sustainable solutions, and this is a structural hydrocarbon. So for us, it's a very easy one to invest in, and it's just right at the top of the corporate mind. First of all, the molecule itself has a lower carbon footprint than equivalent polymers like epoxies and vinyl esters and polyurethanes. So you start with a lower scope 1. As we then move into our customers' factories and they convert, there's a lower energy in order to convert the product. So that's a scope 2. And now we're working on the what next. So we start to look at the full life cycle analysis on what happens at end of life. We're showing compatibility of Proxxima with advanced recycling, which is the Exxon technology that basically takes that polymer and back into new feedstock. So that's really exciting, and we're working our way through that. So in automotive, we're looking at structural parts. So this is chassis replacement, factory boxes, but very much going after steel parts with mainly glass fiber reinforcement for cost reasons, but obviously compatibility with carbon too. So that's the automotive space. We're in the wind industry, doing pultruded spar caps, as well as infused shells and webs. But as we go on the show, we're doing oil and gas. So in oil and gas, it's pipes, filament wound pipes, but also the steel pipes have a thermal insulation on non-composite, but thermoset polymer. So we're in that area as well. And infrastructure. All areas of both built and mobile infrastructure, we are finding applications because the product's really tough. And the other thing about Proxxima we like is it's hydrophobic. It's completely resistant to water. So a lot of polymers pick up small amounts of water, and that impacts their performance over time. We're hydrophobic, we repel water, and as a result, its performance stays good for many, many years. So when we developed Proxxima and ExxonMobil took its commitment to this, it was because it inherently a better product from a carbon footprint perspective. It's only part of the stories we talked about. So what we did was we commissioned the ISO survey, which is ISO 14067, and they assess the carbon footprint from cradle to grade. So from the beginning all the way, and we stopped at our gate. So we go from the oil well effectively through to our factory gate. And this assesses the amount of carbon dioxide equivalents for that. And if you look at epoxy, the average for that industry is just about 7 kilos per kilo. 7 kilos of CO2 equivalents for every kilo of polymer resin made. And then we move down through the vinyl esters that are a bit lower. The polyurethanes are a bit better. And then we come down to Proxxima, which is sitting just around about the 3 level. So a 60% reduction in the CO2. So these ping pong balls are just a graphical representation of a 60% reduction as we move through our product system. Yeah, like most inventions, they take a lot longer than you expect. So we're talking back in around 2012 that a company called Materia in California developed a catalyst system for this. Actually, they got the Nobel Prize for that catalyst, but then it was brought into the polydisactypentadiene system. And they were starting to make their first products around 2015, 2016 at a lab scale. And then ExxonMobil came in and worked with them a few years to adjust the chemical formulation and really to make sure that we could scale it. For us, there was no value in bringing a niche chemical to the market. We needed to make sure that we had the feedstock and the global presence that could scale this to meet its potential. That took us a couple more years in order to make sure that we were ready. When we go out to our customers, business continuity, forward planning, our commitment to grow was really important, and we had to get all of that right. So it was really only around 2022, 2023 that we said, okay, we're ready to go. And now we're on that curve of adopting the market. Our customers are truly infused. They see the value that we're going to bring. I'll show you a part in a minute which shows that there are some engineering changes that have been made. To get the best out of it, you're going to redesign the part. And therefore, we're looking at model lifetimes, and people say, oh, in 2 years' time, I'll put it on a new model. So some of our adoption is affected by that. But if you'd been here earlier, this stand was absolutely buzzing. So as we compare to last year, the number of people who have commercialized or are now commercializing is, I would say, exponential, but from a small base. This is our pièce de resistance for the show. It was literally made just 1 week ago over in China. We all know that as we move towards electric vehicles, those things called a 700 kilo battery that needs to be supported. And the battery box or the tray that sits underneath the car is supporting that weight. Most of the industry has moved from steel to aluminium for lightweighting and performance. And there are very few composite applications out there. And the reason for that is composites doesn't do it in terms of a cost-performance balance, okay? We think that Proxxima can change that because of what it does. So the first part is the viscosity that enables the cycle time, but also the viscosity that enables the design. So let's look at this design, and it is a prototype. We're moving now with Fraunhofer into a full production example of this. But this is 4-ply glass fiber, pre-formed through the shell here. But then what we've done is we've confused the Proxxima through a single gate, because it's such a low viscosity we don't need to double gate it. And we filled this mold in 15 seconds. So very, very fast. But the things that we can do are these. So these rib designs that you see here are pure Proxxima. There's no glass in it. But what it does is it significantly changes the dynamic torsional strength of the shell. And the second thing is it changes the NVH. So we're talking about the resonant frequency of the part, which is the noise that we hear as passengers in cars, all because of these ribs. These are only enabled by the Proxxima low viscosity, all right? It's also super tough. And so particularly if we look at fatigue, so we're talking about if this hits a curbstone or stones hit the bottom of it, you do not want this to crack, because if you crack, you compromise the battery. In here, we've been able to mold in a channel. Well, this is where the rubber seal goes that creates the watertight compartment that keeps the battery dry. All right. So this is where we are, and we're now scaling this up. And we have a system of customer collaboration hubs. We're working with Fraunhofer now in Germany to improve the modeling, the FEA modeling of this. And they will mold the next part, the big one. Then we move across to IACME in Detroit, where we're working on the automation. So how fast can you take a glass preform, put it in there, and shuttle it out again? So that we offer to the industry a full solution, and then we will tell the OEMs and the tier ones, come and see it. This will not be a paper exercise. We're going to prove that we can make a structural part. By structural, a lot of the things today sit on steel beams. These are beams that have been molded in. So you think about functional integration and the ability to mold in sensors, take out the steel beams. That's what this one is about. And the final part on this is you look at this flanged lip up here and you say, well, that must be the weak point. You're going to stress across with all the bolt holes. Well, the trick is we're able to put ribs in behind it, completely strengthening this and the failure mode of it. And that's all enabled by the Proxxima low viscosity and being able to make these combinations of glass fiber reinforced or even carbon fiber reinforced, but with pure resin, changing the design features. I believe that we will have the first commercial part probably within 12 months. It's more likely to be one of the EV startup companies who are moving quite quickly to relatively low production, 5 to 10,000. And I would quite expect one of the Chinese manufacturers to adopt this next up. But we are working with all of the majors, and some of them are on, okay, it's a 3 to 4 year analysis. Some are saying it's 5 to 6. So that will really be the automotive adoption as people embrace a new material. And the second part is just making sure they're getting all the design features in, because that's where you'll really get the value. It is about lightweighting, but it's lightweighting plus, right? So for me, the cost of the part, the structural performance of the part, the sustainability of the part, that is equally important. It's not lightweighting at any cost. But you are right. This is a lighter weight than the aluminium equivalent. Or it's lighter weight than an SMC one. So we are moving in the right direction. I think as we move forward, ExxonMobil, I'll give them a plug, is also looking at some new carbon technologies that will help increase range of batteries and therefore lightweight the batteries. So the world will continue to change. The battery packs that we see today in 2025 are not the ones that we're going to see in 2030 or 2035. But the designs will still lead this, and you'll either take those 700 kilos and use it for range, or you'll shrink it down, and there will be a bifurcation of the market. But just in case you thought that ExxonMobil was oil and gas, here's the hydrogen tank. So again, all of these alternative energies are going to be enabled by Proxxima, which is ExxonMobil's new flagship product.